Hi, in this video we're going to take a look at the examples from Chapter 6, Section 2 using the calculator. The textbook and the videos in Pearson show you how to do this using a table. This will be much easier and much quicker. Alright, Section 6.2 is something called the standard normal distribution. We found z-scores already, and we've already defined standard normal. But it is a normal distribution with the parameters mean equal to 0, standard deviation of 1, and the total area under the curve is equal to 1. So what we'd like to be able to do is to find areas, which are also probabilities, that correspond to z-scores and areas under the curve. We're going to use the TI calculator to find probabilities or areas under the curve when given z-scores. The function is called the normalcdf, and the way we get there is click on the second button, Variables, oops, let me turn it on, second, VARS, there's a little DISTR written above there for distributions. Option number 2 is the normalcdf. Alright, for our first example is bone density test. Scroll down a little bit. So the bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis, a disease causing bones to become more fragile and likely to break. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and standard deviation of 1, so the test results meet the requirements of a standard normal. A randomly selected adult undergoes a bone density test. Find the probability that the result is a reading less than 1.27. So the first thing we do is draw a picture of the standard normal, find our z-score of 1.27, and shade in the area that we're trying to find. On the calculator, for our normalcdf, we have to type in a lower value. We have to type in the interval where we want it to calculate the area. So we need a lower value, an upper value, a mean, and a standard deviation. So in this case, we want to find the area between negative infinity, because remember that the normal curve never actually touches the x-axis. So we're going from negative infinity to 1.27. Your calculator doesn't have an infinity key, or many of them don't. So what we have to use instead is we use negative 1 times 10 to the power of 99, and I'll show you how to get that on your calculator, but that means 0.000099 places 1. So that's as small as we can get. That's negative, or actually, sorry about that, that's negative 1 times 10 to the 99th, which is negative infinity, or close enough to it. So on our calculator, our normalcdf, for negative infinity we type the negative 1. The E scientific notation is right here above the comma, so we hit second, comma, and then 99. That represents negative infinity, comma, 1.27 is the z-score that we want to end at, so that's our interval from negative infinity to 1.27, comma, mean of 0, comma, standard deviation of 1, end our parentheses, and click on enter. So we get 0.89795 on ours. So if we round to 3 places, that gives us a 0.8980. So there's a 0.898, and then that 9 would round up to a 0. And what this corresponds to is the probability that a person chosen at random has a bone density test result below 1.27. Or there's an 89.8% of the people have a bone density test result below 1.27. So the calculator will find the areas for us. Alright, let's look at another example. The next example, using the same bone density test, find the probability that a randomly selected person has a result above negative 1, and that's considered to be in the normal range. So first is to draw our normal curve and shade in the area that we want. This right here would correspond to negative 1 of the z. Okay, now I cut this from the textbook, so it has on there how to use the table. We're going to use the calculator. We want to find the area between -1 and positive infinity. So now we have normal CDF -1. Positive infinity is 1 times 10 to the 99th. And then mean standard deviation. We have our item from last time, so I'm just going to hit second enter, and that will retype your last line. And I'll go in here, use my arrow keys, and go in there and type in, I want -1, comma, 1, the E is second, comma, to the 99, mean of 0, standard deviation of 1. Then I'm just going to delete what we have left here. All right, so that's our key sequence. Low number in the interval, -1 to infinity, mean of 0, standard deviation of 1, and that will give us the area to the right of -1 under the curve. So that area is about 0.8413. So that means there's an 84% of the population has a value above -1. So that would be considered normal. All right, example 5. Now we've looked at areas to the right, areas to the left, and next example is going to look at areas in between. So now we have a bone density test reading between -1 and -2.5, and that indicates a subject has osteopenia, which is some bone loss. So we want to find the probability that a randomly selected subject has a reading between those two numbers. So this one's a little easier to type in because we don't have to worry about infinity. Let me clear. All right, so we go second, variables to get to the distributions, option 2. We're going to type in the lower number, even though it's listed from -1 to -2.5. When we draw the diagram, we see that -2.5 is the smaller value. So -2.5, comma, to -1. That's our interval that we want to find the area. Mean of 0, standard deviation of 1. And we end up with a probability of 0.1524. Right? So that means that about 15.24% of the population has that bone density test reading. Or it also corresponds to the probability that a randomly selected subject has a reading between those two values. So that's using the calculator to find areas when you're given z-scores or you want intervals. The next item is using the TI calculator to find z-scores if you know the area. So this time our function is inverse normal, and our key sequence is second, variables, and we're using option 3 this time. So our next example is using the same bone density test scores. They're still normally distributed. Find the bone density score corresponding to the 95th percentile. That is, find the bone density score that separates the bottom 95% from the top 5. So on our calculator, the way that our inverse normal asks, or what the commands that we need to give, we have to put in the area to the left of the z-score we want to find. Okay, and then the mean, and then standard deviation. So on our first one, we have inverse normal of 0.95, that's the area to the left, 0, and then 1. Okay, let me clear that out. So we go to second, variables, which is distributions, option 3. We're going to type in 0.95, that's the area, comma, mean of 0, standard deviation of 1. And this time we're going to get the opposite, that's the z-score that corresponds to the area of 95%. So over here, our z-score would be a 1.64 if we round it to 2 places. All right, example 7. And our last example. Using the same test, we have a standard normal distribution. Find the bone density test score that separates the bottom 2.5%, and then find the score that separates the top 2.5%. All right, so for our first one, again, our calculator we can only enter the area to the left of the z-score we want. This z-score right here The area to the left of that would be the 0.025. So 0.025, this is to find the cutoff for the bottom 2.5%, mean of 0, standard deviation of 1, and that would give us a z-score of negative 1.96. Okay. Now, since we're looking at exactly the same area on the other side, you know that the distribution is symmetric, so it has to be the positive 1.96, but let's just see how to use the calculator to do that. Okay, again, it will only read area from the left, so we don't want to put in a 0.025 because that's the area to the right. So from the left all the way over to here, we have to take 1 minus 0.025, which would be 0.975. So this time we would type in 0.975. That's the area to the left, mean of 0, standard deviation of 1. And there's our z-score of 1.96. All right, so please use the calculator instead of the table. It just makes it a lot easier. All right, hope you enjoy learning the standard, normal, and areas.